Thermistors. Application of thermistors to monitor the coolant temperature and oil temperature inside the engine. To monitor temperature of an incubator, thermistors are used in modern digital thermostats to monitor temperature of battery packs while charging, to monitor temperature of hot ends of 3D printers, to maintain correct temperature in the food handling and processing industry equipment, to control the operations of consumer appliances such as toasters, coffee makers, refrigerator, freezers, hair dryers like that. They are using thermistors. So next one is thermocouple temperature sensor. So thermocouple work on the fact that when a junction of dissimilar metal heated, it produces an electrical potential related to the temperature. So as per Thomas feedback, when two wires composed of dissimilar materials are joined at both ends, one of the end is heated, so then there is a continuous current which flows in the thermoelectric circuit. This is here they are using two type of metal for identify the temperature. Okay, this is a construction of thermocouple temperature sensor. Here they are using two material, that is two metals. So here iron constant, chrome aluminum, for aerosol nasal, platinum 13 rhodium. So like that using for various range of temperature deduction. That is 0 to 1800, minus 200 to 900, 0 to 1400, 200 to 400. They are using for different range of they are using different materials in the thermocouple temperature sensor. Okay. So application of thermocouple temperature sensor to monitor temperatures and chemistry throughout the steel making process, testing temperatures associated with process plants, example chemical production and petroleum refineries, testing of heating application safety, temperature profile in ovens, furnace and kilns. So temperature measurement of gas turbine and engine exhaust. So monitoring of temperatures throughout the production and smelting process in the steel. So iron and aluminum industry they are using. So these are the types of temperature. Okay, in temperature, if you are putting some temperature into some material, so the physical parameter will be varying. So like that we can calculate the temperature. Okay. So next one is phototransistor, that is light sensor. So light sensor means so when light come to the metal, some material, the material parameters will be varying. Using the parameters variations, we can calculate the light intensity. Okay, light variations, whether light is on or not, off or like that, we can calculate. Okay, that is light sensor. Okay, so in light sensor we have two types. So first one is phototransistor, second one is photodiode. Okay, first we will see the phototransistor. Yeah, light sensor is a device that is used to detect light. So there are different types of light sensors such as photocell or photodiode is used in the manufacturing and other industrial applications. So photoresistor is also called light dependent resistor, that is LDR. It is a resistor whose resistance decreases with increasing the incident of light intensity. That means when we increase the light intensity, the resistance will be reduced. So output will be high. Okay, the resistant materials is cadmium sulfate. Cadmium sulfate they use for the resistance variations. So the resistance of the cadmium sulfate photoresistor varies inversely to the amount of light incident upon it. So photoresistors follow the principle of photoconductivity, which results from generation of mobile carriers when photons are absorbed by the semiconductor material. This is the construction. So this is the cadmium sulfide wire that we defined in a coil like that. If light is put into this material, so this will reduce the resistance of the material. So it will produce some output. Using the variation, we can calculate the light intensity. So application of phototransistor that is used in the computers, wireless phones, televisions, light sensors, automatic control the brightness of the screen like that. Barcode scanner used in the retailer locations work with the light sensor technology. So in auto flash for camera, industrial processing control like that, they are using phototransistor for identify the photo intensity, that is light intensity. Next, photodiode light sensor. So photodiode is a solid state device which converts incident light into electrical current. Photodiode is a solid state device which converts incident light into an electrical current. It is made of silicon. It is consist of a shallow diffused p-n junction. So normally p-n conformation. So when photons of energy greater than 1.1 electron volt fall on the device, they are absorbed and the electron volt pair are created. So the depth at which the photons are absorbed depend on the energy. Okay, that means so it is a photodiode, that is they are using p-n junction. So when for light is dipped into the, when light is produced, the p-n junction hole will be break, so electron flow will be high. So using these variations we can calculate the light intensity. Okay, this is the uh, package for the photodiode. So applications, so camera, so light meters, automatic shutter control, autofocus, photographic flash control they are using. In medical field, they are used for scanners. So industry, they used for barcode scanners, light pens, brightness control, safety equipments in the X-ray detectors, flame monitors. Then automotive industry, they use a headlight dimmer. So like that, they climate control, sunlight detector, like that they are using. So in communication, used in the fiber optic links, optical communication, optical remote control, because in optical they identify the light intensity. Okay, using this we can calculate the light intensity level. Yeah, these are the types. So in this chapter we discussed temperature sensor and light sensor. So in temperature sensor we have four types. So bimetallic, thermocouple, RTD, then thermistor, like that we define. In light sensor, we discussed about phototransistor and photodiode. Okay, so so up to this unit one is completed. So unit one is consists of six chapters. Okay, okay. Thank you all. We'll see in the next class.